Very good morning, Year 9. So today we're looking at covalent bonding. Last week we looked at ionic bonding. So on Tuesday we looked at how you draw ionic bonds, and on Thursday you looked at giant ionic structures. So today we're going to look at covalent bonding. Now, it's quite easy to get a bit confused about the two because there are the two different types of bonding. So I've just done you a quick or short overview of the difference between them. So ionic bonding, which we looked at last week, happens between a metal and a non-metal. The electrons transfer from the metal to the non-metal. Ions are charged particles, so we get ions at the end and they're charged particles. These positive and negative ions are held together by electrostatic attraction, which is strong, and we must draw all of the shells, so we have to draw them before and after and draw all of the shells. Covalent bonds happens in non-metals only. Electrons are shared. Atoms remain neutral because we don't get any charged particles, they just remain completely neutral. Covalent bonds are strong, so the actual covalent bond is strong. I'm going to introduce another term on Thursday and they are weak, but covalent bonds are strong, so learn that at this point. It's really important that you remember covalent bonds themselves are really strong. We only ever draw the outside shell. Because we're not losing or gaining electrons, we're sharing them. We don't have to draw any different energy levels because they stay the same. So what we're going to do is we're going to have a look at two examples of what we call diatomic molecules first. So a diatomic molecule is where you have two of the same type of atom. So this example is chlorine and the next example will be oxygen. Now it's worth bearing in mind at this point that you only have to be able to draw the first 20 elements. Of that, group 4, 5, 6, 7 and 0 are our non-metals. When we take off group 0, because they are unreactive, they've got a full outer shell already, they don't need to do any reacting, we actually have very few. There are only 9 elements that you have to be able to draw as a non-metal. So you're quite fortunate in a way that there's not really that many combinations that you can be given to draw. So the more familiar you become, there's only several that they can ask you to draw. So let's have a look then. Let's start with chlorine. So whenever you've got this, we know it's covalent bonding for two reasons. Number one, on an exam paper, they'll give you the outline. So if you see this outline, instantly you know it's covalent bonding. If there's no outline, that means it's ionic. The second thing is that it says chlorine Cl2. Chlorine is in group 7. We know that group 7s are non-metals. We've got two non-metals, so it must be covalent because there's not a metal in here. It's got to be covalent bonding. Whenever we draw covalent bonds, we draw them before and then the after picture. If in an exam paper they've given you the outline, take your time to draw the before pictures because it makes sure that you get those marks. The amount of times that people lose their marks because they get maybe the inside bit right but the outside bit wrong, or the outside bit right but the inside bit wrong because they haven't drawn the before. So take your time, it's factored into the exam paper. So chlorine then. Chlorine is in group 7. If it's in group 7, it means it has 7 outer shell electrons. So we have 1, 2, 3, 4, 5, 6, 7. It has 7 outer shell electrons. Remember, we only look at the outer shell with covalent. Now it wants a full outer shell, which means it needs one more electron. So what it does, however many it needs, that's how many it shares. So if it needs 1, it will share 1. If it needs 2, it will share 2. If it needs 3, it will share 3. If it needs 4, it will share 4. So this is it needs 1, it will share 1. Now I'm going to draw another chlorine. This is just to get you in the habit. I know they're both the same. However, it's worth getting in the habit for when they're not always the same, if that makes any sense. So this chlorine also has 7 because it's in group 7, 7 outer shell electrons. It also needs 1, so it's also going to share 1. So let's look at this chlorine first. It has 7, it needs 1, it's going to share 1. So it puts 1 of its electrons in the overlap. We now have 1, 2, 3, 4, 5, 6 left. 1, 2, 3, 4, 5, 6. They stay on the outer shell. So initially I should still have the same here as I do up there. 1, 2, 3, 4, 5, 6, 7. Perfect. Over to this one then. Needs 1, shares 1. So it's going to put 1 in the overlap. It's got 6 left. 1, 2, 3, 4, 5, 6. Done. Now I'm just going to check because chlorine wants 8. 1, 2, 3, 4, 5, 6, 7, 8. Whatever's in the middle counts for both. This one then, 1, 2, 3, 4, 5, 6, 7, 8. We're good. So the next example then we'll have a look at is oxygen. So oxygen is another diatomic molecule. So it's another one where we have 2 of the same. So again, I know it's covalent for 2 reasons, 2 non-metals, and we've got our overlap. So oxygen before, oxygen is in group 6, 1, 2, 3, 4, 5, 6. It has 6, it needs 2 to have a full outer shell, so it's going to share 2, because remember however many it needs, it shares. This oxygen over here, also in group 6, which means it's got 6 outer shell electrons. Remember whatever group number it's in, that's how many outer shell electrons it has. So it's in group 6, so it has 6 outer shell electrons. It also needs 2 more to have a full outer shell, so it's also going to share 2. So we look at this oxygen here, needs 2, shares 2. It's going to put 2 in the overlap. We have got 1, 2, 3, 4 left. 1, 2, 3, 4. Done. This oxygen here needs 2, shares 2, so it's going to put 2 in the overlap. Little hint, you should always have an even number in the overlap. So if you count and you've not got an even number, you've gone wrong. So 1, 2, it's got 1, 2, 3, 4 left. 1, 2, 3, 4. Done. Again, I'll just double check. 1, 2, 3, 4, 5, 6, 7, 8. Yep, that oxygen's got 8. 1, 2, 3, 4, 5, 6, 7, 8. Yep, that oxygen has also got 8. So sometimes you can get them where you have different types of element, which is brilliant and interesting, but it sometimes throws people a little bit. So we'll have a look at a couple of examples now. So the first example we're going to have a look at is carbon dioxide, CO2. So I've got 1 carbon and I've got 2 oxygens. So let's start with this carbon. Carbon is in group 4. That means it has 4 outer shell electrons. Some of you wondered why I draw in pairs. It's just so it's easier to count. It's as simple as that. If you put them wherever, it makes it a lot harder to count and it makes it easy to make mistakes. If you put them in pairs all the time, it just makes it easier to see how many you've got. So 1, 2, 3, 4. So carbon is in group 4, so it has 4 outer shell electrons. That means it needs 4 more to make it a full outer shell. It wants 8. So it means it's going to have to share 4. This oxygen is in group 6. 1, 2, 3, 4, 5, 6. That means it needs another 2. It's going to share 2. Now you'll see we've already done oxygen up here. So actually you can start to see now we get repeats. This oxygen is also in group 6. So it also has 6, needs 2. It will share 2. So this is a bit of a weird one because we've got 1 carbon and we've got 2 oxygens. So I'm going to just show you here. The carbon needs 4, so it's going to share 4, but it's got 2 overlaps. So what we do is we split however many it needs into each overlap. So if there were 3 overlaps, we'd split them into 3. It will always be the right number, don't panic. So it needs 4, it's got 2 overlaps. So what we're going to do, we're going to put 2 in that one and 2 in that one. So it needs 4, so it's shared 4 overall, and it's put 2 in each overlap. It actually doesn't have any left. 1, 2, 3, 4, 1, 2, 3, 4. So carbon's done. Right, this oxygen here then needs 2, shares 2. So it puts 2 in the overlap. It has 4 left. 1, 2, 3, 4. 1, 2, 3, 4. Again, you're going to start seeing some repeating patterns. Oxygen needs 2, shares 2. So whenever I draw it, I'm always going to have 4 more left over. This oxygen over here then needs 2, shares 2. So I'm going to put 2 in the overlap. That means I've got 4 left. 1, 2, 3, 4. Done. Let's count them up just so you can see. So this oxygen wants 8. 1, 2, 3, 4, 5, 6, 7, 8. This oxygen wants 8. 1, 2, 3, 4, 5, 6, 7, 8. This carbon wants 8. 1, 2, 3, 4, 5, 6, 7, 8. Remember, whatever's in the overlap counts for both. Final one. Nitrogen fluoride. Okay, so this will be one of the harder ones that you'll have to draw. I am just going to give you a bit of a hint in a second as well, because hydrogen's slightly different, but it's easy, it's just slightly different. So before I have got nitrogen. Nitrogen is in group 5, okay, which means it has 5 outer shell electrons. It wants a full outer shell, so it needs 3 more. So it's going to share 3. Remember, however many it needs, it shares. Right, first fluorine. Fluorine is in group 7. 1, 2, 3, 4, 5, 6, 7. So it has 7. It needs 1. It will share 1. I've got another fluorine because it's N1, F3. So 1, 2, 3, 4, 5, 6, 7. Again, it needs 1, so it's going to share 1. Remember, all non-metals other than hydrogen want a full outer shell, and that full outer shell will be 8. So other than hydrogen, they all want 8 in that outer shell. So you basically, whatever the number here is, you need to make it up to 8. So if it's got 5, it needs 3 more to make it to 8. If it's 7, it needs 1 more to make it to 8. Right, final fluorine has 7, needs 1, shares 1. Right, I'm going to start with my nitrogen then. So we've got 3 overlaps here. It needs 3, it shares 3. Look at that. So the most sensible thing to do here is for this nitrogen to put 1 in each of those overlaps. I told you that whenever it shares, it will always be a number that's easy to work out where it goes. So with carbon, we needed to put, it needed 4, so we needed to split it between the 2. Okay, so when we had this one here, it needed 4, so we put 2 in each. Okay, because 4, 2, 3, and we've got 3 overlaps. Right, this fluorine here has 7, needs 1, shares 1, so it's going to put 1 in the overlap. Oh, hang on, I've not finished nitrogen. Right, nitrogen, sorry. 1, 2, 3 in the overlap. So I've used those 3 there. I've got 2 left. Yeah, so I've got those 2 left. Right, 1, 2, 3, 4, 5 crosses. 1, 2, 3, 4, 5 crosses. I'm good. So this fluorine needs 1, shares 1, so it puts 1 in the overlap. It has 6 left. 1, 2, 3, 4, 5, 6. This fluorine needs 1, so it's going to share 1, so it puts 1 in the overlap, and it has 6 left. 1, 2, 3, 4, 5, 6. This fluorine here needs 1, so it's going to share 1. It's got 6 left, so I'll pop those around the outside. Right, let's double check then. So nitrogen wanted 8. 1, 2, 3, 4, 5, 6, 7, 8. Perfect. Fluorine wanted 8. 1, 2, 3, 4, 5, 6, 7, 8. This fluorine wanted 8. 1, 2, 3, 4, 5, 6, 7, 8. And this fluorine wanted 8. 1, 2, 3, 4, 5, 6, 7, 8. Now, your task for today is going to be, you're going to do you've got 3 diatomic molecules to have a go at. Nitrogen, sulfur and carbon. And then you have 3 that are a bit more like this one to have a go at, which is water, methane and silicon dioxide. Let me just remind you at this point that hydrogen only wants 1 more electron. Okay, so remember that hydrogen is a non-metal, but it only wants 1 more. It sits in a weird place, and that is because hydrogen only has 1 electron on its outer shell. So it's worth making a note of this because hydrogen sits in the middle of the periodic table, but it is a non-metal. So hydrogen has 1. It needs, 1. So it will share 1, and that is always true of hydrogen. It only ever needs 1, it will only ever share 1. Just bear that in mind when you have a little look at water and methane in particular. Answers are provided on the following slides so that you can see how you would draw them out. I've only drawn this bit out for you, so what I would recommend is if you look at this bit and it doesn't match up with what you have got, either email your teacher or email me and I'll happily explain where you've gone wrong. That's absolutely fine. It's just for ease on the PowerPoint so I can upload it to files because it doesn't like lots of photos. So just again, I've only drawn that bit out, but if you do get something completely different and you can't work out why you've got it wrong, just drop me an email or drop your teacher an email and they'll be able to explain. No assignment due today, just have a little go at the covalent bonding. And on Thursday we're looking at giant covalent structures. Have a good day. Bye.